Yeah, so whatever we discussed in the last two sections, we'll try to recollect about it, and then we'll go ahead concluding about it. What all exact? What are the like different tools we are going to talk it in our DevOps journey, and what about our course curriculum, and to make it the successful of the journey, what we are going to do that. So these are all the things that we are going to look into that. But yes, if you just go ahead quickly, so some keywords, not only keywords like understanding about application side. Yes, application we are hosting is nothing but there are the three main layers that is helping that. Yes, without infra, so there is no concept about that application. Yes, infra layer is required about the networking, storages, servers, and operating systems. And once that infra is ready, then we need to set up the platform before hosting that application. That is the Java platform or .NET platform or Python platform. So the platform layer is important. And once that's all these have been set up, that then we can go ahead working or the hosting that application and application the required data. So there are the three important layers that we are talking about it to host that application. But any application, if you talk it, that is having that some the process models. Yes, like the planning of it, execute it, inspect it, and accept it. So to perform all these stages, as we're talking, that the management team, they are going to use it, the different methodologies. And one of the methodology that's the initially which they were using about it, that as a traditional approach, that's a waterfall approach. But in the waterfall approach, the main the stages and the teams, if you just observe that, yes, there are all the stages which you are trying to understand about it. It's important, like if you just conclude it here, yes, the development environment. So that is developers are involving that, and a testing environment where the quality that will be verified by that development team. They need to have the testing servers, and as well as testing team, they need to have the testing servers. And once testing is done, then that application is required to move into that UAT environment. That's we can say the pre-prod environments. And once it is approved in the pre-prod environments, we are talking about it a production environment. This is all important, which we should remember it always. As a project we are talking and we are going to work it is nothing but, yes, we are going to work it with these environments and with these teams. So in the project, it is not going to manage it by only one team. So we'll be having the development teams and testing teams and client side and operation engineers. Yes, as a DevOps engineer, we need to coordinate it, all these teams. Yeah, we were concluding about it, important stages and the teams, and the stages point of view, the important environments. And in that environments, what are the different teams are directly or indirectly are involving that, and what is their roles. So this is the first thing which we are trying to understand about it. But waterfall approach, it was having some challenges and the failures of the projects. So why it is having the challenges of the failures is some communication gaps are happening that during that implementation of that application among the requirements and requirements of the customer side and as well as developers and testing team. And not only that, during the release process also we have some communication gaps between the development teams and testing teams and operation teams. But how do you overcome that all these challenges? Yeah, how do you overcome that all these communication gaps? Is because of these communication gaps, so projects are getting failed and on-time delivery is getting failed and budget is increasing that. So these are all some challenges that we have that. But why we have all these challenges is, so why do we have all the challenges if we try to understand it? Development team, they are going to focus mainly on these activities. So they need to implement the code, and not only that, code integration, code quality verification. Yes, whatever the code they are implementing, this they need to make sure that the code quality and running their test cases from the development side, and they should have the proper communication. And they are doing that all these activities manually before. Yeah, all these I mean, not only just implementation from the development. Whenever we talk at all these activities, some challenges I mean, the among the development team and testing team's point of view. Yes, they need to work it on that, understanding the functionality and implementing the test cases and running those test cases. But running all these test cases, before they were doing the manual approaches and with manual evaluation, manual promotions, and they were having some communication gaps while understanding the requirements. And if you move to that, like a release process is another important team, operation engineers. So this team objective is entirely different. So code deployment is the developers, whatever the code they are implementing, that the code to deploy to whatever the infra changes, platform changes, application changes. So they need to release it from the development to that staging to that UAT to the production. So they will be having that deployment changes. And how fastly we deliver those changes, that is another important objective. And they need to manage that infra changes. And if they have this the communication gaps among the development teams and the testing team with operation, so then we'll be having that some impact on the project delivery. And if they are doing that all these activities before that's manually, but we need to provide the solution with the automation. Yeah, so these are all important challenges that we're trying to understand it. But yes, like a great software, if you'd like to deliver it, yes, we need to have the better communication among the teams. And we, instead of having the manual approaches, we need to have that automation approaches and fast delivery. So how fastly we deliver one change to the production environments, that is also important factor. And make sure that the development and production infrastructures are the same, and how fastly we are getting the feedback from the customers, and as the feedback point of view, applying the changes and releasing the changes. So these are all some key factors that we are trying to understand it. But in the waterfall approach, whatever the factors which are expecting, that is not happening that. So we don't have this the better communication among that the requirements development and testing before, and automation approaches are not there on the developers systems to overcome that. What is the model it has come, that is agile model has come up with that. Yeah, as we're talking that the agile some terminologies, yes, the product backlogs, that is a small the user stories which will be released as a sprint, which will be having that like a 2 to 4 weeks of the sprint. And that 2 to 4 weeks, that's like every day having the meetings, and in that meeting interacting with the teams. So like what are the inputs that is required or what they have done, so that is discussing, and what is today's the activity which has been done, and what is the tomorrow plan. So every day the reviews of it, and releasing about it the small sprints of the code, then finally the complete product release. Yeah, agile has introduced into the projects, but agile with that sprint model with the small iterations, some lot of that like I mean the impact on the development teams. So continuous code integration, continuous build activities, continuous testing activities, continuous deployment activities, continuous, yeah, review of it. So this is the life cycle. So this is not ending, it never ends the story. The project is continuing is nothing but, yes, this is the life cycle we are expecting that in each iteration. But how do we handle that? So automation approaches of this iteration. Yeah, so there we are trying to understand about it, some automation approaches. So that is the main thing. If you just observe that the automation approach in the agile process, continuous integration, yes, among the development team. In the development team, like not only just one developer, so we'll be having the 10, 20, 30, 40 or 100, but all the 100 developers, yes, we need to have the proper the integration, communication between them. So continuous integration, yes, we need to come up with that automation approaches. How do we provide it? We'll come back. And another challenge which we have to see is in this agile process among that developers and the testing team, continuous testing. But how do you do the automation of this one? Yes, manual process now it is moving to that automation approaches. With these automation approaches, then we will be having that enhanced communication among the teams. So one of the key factors that we are talking about it, enhanced communication. But we are not going to talk it, boss, do about your work, do about your work, do about your work. No, we are not going to talk like that. We are going to automate about that developers related, the code integrations, the code quality checking, code build activities, code testing activities, code release or deployment activities. So we are providing the solutions to the teams. So in that, so the important two activities with the agile process model among the development teams and testing teams with the functionality side is continuous integration, continuous testing. There are the two important activities. But with this agile process, it is not completely solved that the gaps among the teams. Agile is introduced here, good, but it is helping on this understanding about the requirements from the customers to with the developers and testers. And with Agile, some challenges we are understanding that continuous integration, continuous testing. So those challenges, how do we come up with that automation approaches? So this is one thing, one part. But this part is not ended in the process. But we have those developers, testers, and operation teams communication also. It's required. But how do we have the better communication between the developers and testers and operation teams? How do you overcome this gap? That's DevOps. Yeah, we are working this as a DevOps engineer is nothing but think it about it. We are going to coordinate it to development teams and testing teams and operation teams. To coordinate it, we are going to become as a developer and operation engineer, DevOps. Developer and operations engineer. But what we do, we develop it. And what are the operation activities we'll perform it? Yeah, development, automation we are doing is nothing but some automation scripts we need to write it. That's point of view we are going to become as a developer, as a DevOps engineer. And as well as, so we are going to work like as an operations engineer. So DevOps role, that is the engineers required now, these engineers who are helping that, bringing the teams together. Especially among the development teams and testing teams and operation teams to have that enhanced communication and automation approaches, fast delivery of the changes, having the same infrastructures, quick feedbacks. How do we handle all these cases is that is DevOps. But in this DevOps, so what are the main activities we are trying to understand is continuous integration, continuous testing to bring that the quality, continuous deployment to keep on releasing the changes from one environment to another environment. That could be infra changes or the platform changes or application changes, and continuous monitoring. So with these are all some principles have been designed for the DevOps teams. So after considering that, how to get it the better coordination communication among all the teams is, so DevOps side it has been decided some principles. So what are those 5 principles? Continuous integration, continuous delivery or the deployment, continuous testing, continuous monitoring. So there are the 5 principles. So are you clear about this one? Are you following about the points? So up to this, which we had it yesterday, right? Yeah, so we had that, this like, I mean, this was the concept yesterday which we were trying to understand it. Are you clear about this now? Now we are going to talk at those five principles. Whatever we are talking, that integration, and how do you set up the similar environments, and how do we define that delivery or the deployments continuously, and how do we define the continuous testing, and how do we define the continuous monitoring. So with these principles, we need to work it. Once you join to the project, so what the developers are doing that, what are the like yeah, continuous integration challenges they have? Are they doing the manual approaches? If they are doing the manual, then we need to come up with the solution. Yeah, DevOps wise or DevOps engineer wise, always think that problem statements are there in the process among the development teams, testing teams, and operation teams. And those problem statements, the manual approaches are like the which they are doing about it manually, or challenges which they are facing, that or during the delivery if they have those any the late deliveries. So we need to identify the problem and we need to provide the solutions. But how do we provide it? How do you do that? That's we need to learn it. As DevOps principles, which we are trying to understand it. Yes, that's the five principles to make the successful in the process model. We are going to, I mean, they are going to recruit us, as simple as it is. Why the suddenly the DevOps engineer role in the market? Before, mostly we hear about that, okay, that's a DB administrator or network administrator or system administrator or a development teams or testing teams or some middleware administrator. We were looking, I mean, they were looking at these kind of the roles before, but now they are looking about it. Cloud engineers, cloud, and with a DevOps process model. But what is the need of the cloud? That's will come back. We have the story on it. That is separate. But still we are understanding the importance of the DevOps. Even if you know this, the cloud, AWS or Azure, that is not enough. You should know the process. That is a DevOps also recommended. If you just add it about that AWS, so we don't see that much requirement. But DevOps, I mean AWS with the DevOps process model, definitely about your resume is weighted. Yeah, that's why we're concentrating mostly on that DevOps. But this DevOps process model, finally, which we should know, on premises or cloud infrastructures. That's will come back whenever we are learning. Yes, first we are learning about it. Yes, the cloud, and after that, the cloud with DevOps. Are you clear about this one? Have understood that the problem statements now among the team? What are the main problem statements now? Problem statements, that's about like what are the principles we are talking, that is integration challenges, deployment challenges, testing challenges, monitoring challenges, delivery challenges. These are all the challenges. But in the DevOps point of view, we are talking that they're all as principles. DevOps engineer principles. But infra wise, if we just talk it, or teams wise, if we just talk it, they're all the challenges. But from about our side, we are working this in the project as a DevOps engineer is nothing but we are looking with these principles. How do we give the solutions to the development teams, testing teams, and operation teams? Okay, now let's move into that. So what is the like a first continuous integration? How do we give the solution in the continuous integration? Then continuous delivery deployment. Then continuous monitoring. How do you provide the solution? Finally, continuous testing. Yeah, let's look at about that. So there's all these the important things. The first one is exactly the continuous integration. Yeah, what is a continuous integration? Now we are the like I mean we are entering into this more detail of the more details or more stages are internally the process model of the integration. Integration, what are the challenges? This is especially among the development team, in the development environment. Suppose if I am the developer, I'm working for the Gmail application and I'm implementing the functionality of it. Like let's think of it a sign in or sign up page. So I will be having this my local system, right? Yes, once I join to the project, they give the laptop or desktop to me, and where I can set up this my development environment to implement the code, the functionality of Gmail application. But finally, that application related code. So I am not only the only one developer to implement the entire Gmail application. Gmail application we have sign up, sign in, inbox functionality, trash functionality, spam functionality, so many functionalities. So they recruit the more developers on the base of the plan. But at the end of the day, all the developers, whatever the code they are implementing for the Gmail, they need to store it in one of the repository. Repository is kind of server, repo, where storage server simple. But what do we store it here? Source code. The developers, whatever the source code they are implementing, we store it here. So we have that source code repositories in the market. We will use it, that source code repository. That is a Git or GitHub, Bitbucket. We have the different tools. Whenever we talk it, that tool will come back. Yeah, so the developers, whatever the code they are implementing, they don't keep that in their local system. End of the day, all the developers, the code, it should be managed in one centralized server. That's we can say the source code repository. That is Git, GitHub, which we have in the market. But any code is updated here. That means a developer from his local system, he is updating to the project central repository. Immediately we need to start checking about the code quality, code errors, right? So whenever any developer push the code to the source code repository, what we are going to define is we are going to define the pipeline. So we are going to work it on this pipeline. So in this pipeline, but how do you define or how do you implement these pipelines? Pipeline, that is a sequence of steps or sequence of the stages. But pipeline, how do we implement it? We use the Jenkins, a CI server, continuous integration server. So this server, which will be integrated with the source code repository, and if any update is happened, that means any developer push the code, any developer, doesn't matter that. So if they are updating any code to here is nothing but they are saying that their code is okay, their code is ready. If any developer commits the code to the source code repository, yes, we use the Jenkins or the CI server, keep on monitoring about it. Yes, if any update is happened, we start the pipeline. But in that pipeline, what is the first stage that we're expecting is, yeah, any update is happened, we pull that code, that means get that the complete code of the source code repository to the build server or CI server and start the pipeline process. But in that pipeline, what is the first stage that we're expecting is the developers, whatever the code they have committed, is it having any errors or not? We need to check it. Unstable code, the developer, they should not update to the remote repositories. Yeah, so any developer is committed here, we are not going to do that. We are doing that automation. But which server we are using here? Jenkins kind of the servers we are using to keep on monitoring about the source code repository. Any developers that push the code to the repository, immediately we are taking this code to the about our build server, and we start about it. First of all, is it having any errors or not? That's we'll say that compilation. If you don't have any errors in the compilation, okay, it's good. Developer, they didn't do that any mistakes. We are okay with that. We can continue to the next step. But what is the next step? Code quality verification. Check that the code whatever they have committed here, they are following that all the coding standards or not. Coding formats, they need to follow it, and they should not write that username and passwords in the code. That is security vulnerabilities verification. Passwords, they should not write in the code. So all these things that is required to verify it, that's will say that the code quality. But if that the code quality is failed, we stop the process here and we send the mail to that development team. Was about your code quality standards are not followed, so please check it and review once again. But it's a quick review. But how are you going to do that? Are you going to do manually verifying the code quality whether they're following it or not? No. We use it one tool here, that is Sonar Cube. This helps about it to check it about the code quality, and it generates the reports. If the report all the rules are valid, then it accepts it. Otherwise, it will be failed. If it is failed here, we stop it here. We send the mail to the developer, and developer has to review it, and again he has to commit back. He is committing again is nothing but we are doing that compilation, and we are again running the code quality. That's why we say the continuous integration. This is, we are not doing the manually, that manual approach which they were doing the before, we are converting into that automation approach. But how we are doing that automation approach? Here we are using the Git GitHub. Here we are using the Jenkins. Here we are using the Maven for the compilation. And code quality and approvals point of view, here we are going to use it the Sonar Cube. Different tools integration. So if the code quality is good and approval is done, that means we don't have any errors in the code and code is good. All the security vulnerabilities have been identified. That's fine. What next? So next, developers related test cases, we will run it. So that is, we are talking about it unit test cases. Yes, we need to run it all the unit test cases which are implemented by the development team. But are we going to run it manually? No. We use the Jenkins and we take that the code or test cases which are implemented by the development team from the source code repository, and we run the test cases. If all these test cases are passed, then we'll promote to the next stage. If it is failed, we stop it here. We send the mail about that test result report sharing. Was there all the test cases which was executed? These are all passed. These are all failed. Then the developer has to review about it, the failed test cases, and he has to fix that errors. Again, he has to commit the code to the repository. Again, it will be started about this process. Are you following the points? Is it clear? Any queries, questions, please? Sorry. Yeah, this Saturday mode, we can understand it. Okay, fine. Anyway, let's continue. Yeah, so if all the test cases are passed, the developers related test cases. Then which will be promoted to the next stage. So what is the next stage? That's which we say that as like a packaging of application. So that is converting about the complete source code into that build format or binary file format. But what is it, the binary? We will talk it that more into that whenever we start working on this. Yes, we go for the creating the packaging of application, and these packaged application that will be managed within the somewhere it has to be stored, right? All these packages. That's point of view we use it that another repository, that is artifact repository. So here source code we are storing, and the source code which will be compiled and code quality verified and unit test case that will be evaluated, and then it will be packaged is GIF file or .exe file or .msf file on the basis of that application type. But these packaged files we don't keep it on the build servers, so we need to upload it to that artifact repository. Here again we use it another tool, that is Nexus. So Nexus is another the tool which we use it in the process where to store it all the artifacts. So once the package is ready and uploaded, we take this package and we'll deploy to the servers. So this is about platform, Java servers or the Tomcat Java point of view, or a .NET point of view, IIS server or Apache servers. So we take this application and we'll deploy to the servers, that is hosting of application. And once this application is ready, we go for that running the test cases, that is post deployment test cases or integration test cases. So this is the process which we'll be having. So if all these stages have been completed, that's we can say that integration is done. Any developer committing the code, so Jenkins is going to keep on monitoring, and if any update is happened, immediately the code, it will be pulled to the build server, it will be compiled to verify that all the errors, and then it will be verified the code quality. And if the code quality is okay, then it will be approved and it will be promoted to the next stage, that is running the unit test cases. And if unit test cases are successful, then that will be packaged, that entire application code, into that binary file, and this binary file that will be stored in the artifact repository. And once that application is stored in that artifact repository, then that's going for that deployment to the servers. And after deploying to the servers and the platform is ready with that application, then we go for running the post deployment test cases which are planned for this application. If you would have completed this process model up to the testing servers deployment with all these steps and with the pipeline, we can say that integration is done. Continuous integration is done. But continuous integration is not the solution. So deploying to the only testing servers, that is not enough. So once the testing servers are ready with our approvals and from the testing team, then we need to take it and application we need to move to that next environment servers. Yeah, suppose here if you just observe the developers, whenever they commit to the version controlling tool, and as we're talking about it, so get the code and do that, like run the unit test cases and create artifacts. But these artifacts we go for deploy to testing environments, the change release here, testing environments. Suppose here we have that like something, two servers, so you need to deploy this artifact to the two servers. Then what are the test cases are planned here, and run the test cases. So deploy it and run the test cases which are planned here. If that is approved, that means all the test cases are passed. Then move that application to the next environment, that is non-functionality environment. But here let's assume that you have the 4 servers. So you need to deploy that application to the 4 servers and run the test cases which are planned here. So that is deploy it and run the test cases. If the test cases are passed, then it will be approved. Or otherwise it will be rejected here. Then it goes back to the development team and they need to review about it, the which test case are passed or which test case are failed. Then as that failed test case point of view, they need to fix that issues and again commit it. And any commit is happened, then about our continuous integration server is going to pull that code, running that unit test cases and creating artifact and deploying to these 2 servers. Then run that all these test cases. Now it is passed. Then deploy to that UAT server, the 4 servers which are planned. Then if all the test cases, if all the test cases are passed, okay, approve it. So this is the process. I mean, the continuous, it never ends. Okay, here it is approved. Then take the change and release to the next UAT environment. So UAT environment, let's assume that 4 servers which have been planned here. That means you need to release that change to the 4 servers and get ready of that application to run that all the UAT test cases. So if all the test cases are passed, yes, that is a promote to the production environment. That is live environment. Here we have, let's assume, the 10 servers. So 10 servers we need to deploy it and make sure that the 10 servers are ready for that to accept the request from the client and processing the request. So here if you just observe that after the continuous integration we are talking about it, deploy it and run the test cases, then get that approval. So then move to the change to the next environment, deploy it and run the test cases and get that approval. Move to that next environment, that is deployed, test it, deploy it, test it. So delivery or deployment, if we just talk it, delivery or the deployment pipeline, if we just talk it, deploy it here 2 servers and run the test cases. Deployed here the 4 servers and run the test cases. Here I deployed the 4 servers and run the test cases. Here I deployed to the 10 servers and run the test cases. So how fastly we deliver the change, this is the point we are talking that here 2 plus 4 plus 4 plus 10, that is almost 20 servers which we have. But how fastly we deliver to each environment and how do we run the test cases? Then if it is positive here, then how do we deliver the change to the next 4 servers and how do we run the test cases? This is the fastly delivery the process because we'll have the number of environments and in each environment number of servers. So this is the delivery or the deployment. But what is the delivery or the deployment? Why we are using the 2 keywords here? That's I'll come back. Delivery or the deployment to understand it. Finally, if we conclude it, the DevOps, that is helping that development teams and testing teams and operation teams with the continuous deployment, continuous testing. Deploy it and test it and move this next environment, deploy it and run the test cases and move to the next environment, deploy it and test it until to the production. That is objective. So DevOps is bringing continuous deployment, continuous testing. And finally, automation, what we need to do that is DevOps process model point of view, continuous testing, continuous deployment, continuous delivery, continuous monitoring. These are all some important factors from the DevOps process model. Now if you combine that Agile and DevOps, Agile, during the functionality implementation side, and that functionality once it is ready, DevOps is deliver it, and release it, right? DevOps is deploy it and run the test cases. Agile is, yes, like prioritize the work, design it, development it, build it, and run the test case. This is the integration. But once integration is done, then take the change, release to the next environment and run the test cases, release to the next environment, that is deployed and run the test cases. That is until to the production. If you combine the both Agile and DevOps, continuous integration as a delivery or the deployment, that is a final conclusion. Why we are talking, that's all these things: integration, delivery, deployment. So total they are using the two methodologies or the two process models. One is Agile, second one is DevOps. Agile is mostly into that integration part, but DevOps is that integration. Once it is done, how do we fastly deliver it, deploy it, and run the test cases, deploy it and run the test cases which are planned in the next environments. So are you clear about these keywords? Are you following the points, everyone? Any queries, questions, please? But what is the difference between the delivery deployment? We will come back. But so Agile and DevOps, these are all the two important process models currently which are going on. But from these process models, what are the things we need to automate? It is continuous integration challenges, continuous testing, continuous delivery, deployment, and continuous monitoring. These are all the things that we need to automate it. That is a conclusion for the DevOps engineer. But how do you do that? Yes, we are talking that some tools, right? Source code repository, continuous integrations our tool, code checking tools, build tools, artifact repository tools, deployment servers, testing tools, how fastly we deliver the change, the tools. They're all the tools. There's a combination. Are you following the point? Okay, finally, if you conclude about it, Agile and DevOps process model. So what are the main activities we are expecting? Integration, testing, continuous deployment, continuous delivery, and continuous monitoring. These are all the main 5 principles that we are concluding. But what is the CI and the CD? Continuous integration, we know it, but in the CD we are talking about the delivery or the deployment. But what is the difference? Yeah, these are all very important. In interviews also they will ask you, what is the continuous integration and what are the stages you are working this in the integration? And what is the delivery or the deployment and what is the difference of it? Yeah, continuous integration, as we're talking that, taking the code and do the build activities and run the unit test cases, deploy to the staging servers, and what are the test cases which are planned, run all the test cases. It should be automated, this process, where we should not involve any manually. If the developer commits the code to the repository, it should be done these things automatically. For each commit, whatever he is doing that to the repository. Okay, that's where understanding integration. But what is the delivery? Yeah, once integration is done, that is build it and run the unit test cases and apply to the staging and run that run the test case which are planned in the staging environment. Once it is done, but final objective is promoting finally that release to the production, right? But some of the projects, everything we cannot do automation. Some of the test cases like testing team side, they cannot give the guarantee everything is automated, especially some telecom domains like device based applications. Then some manual approval is required. If you would like to promote to the production, some manual approval is required here. So if about our project is designed with the continuous integration and promoting the changes to the production with manual promotions, then we can say that is a process model is continuous delivery process model. So manual promotion here maybe that like marketing team sometimes they come up with that. Functionality teams they need to check it and they need to approve it. Or a testing team they need to check it and they need to approve it. Yes, there's manual approval is there in the process. That's we can say that continuous delivery. But continuous delivery is not the point. So as we're talking that continuous deployment also, what is a deployment is if you're able to automate it everything this entire process. That means from the developer to that to the production. If everything is automated, then we can say that a process model is continuous deployment. Delivery is manual promotions. Deployment is automation promotion. Suppose if you just talk it like Amazon Web Services, the social networking site. On an average, they are doing that 1400 changes to the production environment. 1400 changes every day they are releasing to the production environment. Think of it, how it has been automated everything. That is, they are using deployment, continuous deployment process. But if they have the manual, no, that is not possible. Those many releases to the production, manually verifying and checking about it and approving that takes some additional effort, additional time. Yeah, continuous integration that is up to the staging environments, but staging to the production, if it is done with the manual promotions, then we can say this delivery. But staging, once it is integration is done, if you are promoting to the production up to that with the complete automation approaches, we can say the continuous deployment. Good, yeah, thank you. Yeah, now let's conclude about it. So what exactly that's we are doing that in the delivery at the deployment? As like a DevOps engineer, okay, we understand now all the points. But as a DevOps engineer, what do we need to do that in this integration, delivery, or the deployment, or monitoring? So before they were doing the manual approach, but we need to convert into that automation approaches. Yeah, the manual how they were doing is so launching that the server, and then installing the Java, then installing the Tomcat on top of it, and configuring the Tomcat and deploying that application on the Tomcat. So all these things they were doing that manually before, but now we have the tools. So we'll come back. That's we are going to learn it. So now we are going to do that automation infrastructure provisioning. That means launching these the infra that is about server, operating systems, and storages and the networks. We are going to use it that one of the tool that is Terraform, and we using this Terraform we are writing that code. We are writing the code to provision the server or to launch the system. We don't go for this like manually launch it. So we use the Terraform. We are going to write the code to launch that networks, storages, virtual machines which are required for the project, for the different environments. So that is infra provisioning, we will call it that. That's we are going to learn the Terraform in our course. And next, platform provisioning, that is installing the Java, installing the Tomcat and configuring the Tomcat. These things, how do you do that automated? So this is a platform. Once the server is ready, then we need to set up all these tools which are required for that application. But this is a platform provisioning. We are going to learn it about that Ansible and shell scripting approaches. How we are doing that automation? Yes, infrastructure to launch it. that is networks, storages, servers, operating systems, we are going to learn the Terraform. And how you are going to provision the platform which is required for that application before deploying? Yes, we are going to learn it about Ansible and shell scripting. And how we are going to deploy that application? So that is we are going to use it some build tools to manage that application, build process, compilation, running the test cases. So we are going to use it, some tools for that. Yeah, with all these tools, we are going to automate it. So here, if you just observe the manual approach, how do we convert indices to that automation? We have the concept of the templates. Either we can use, we will use the templates. With the templates, we'll provision the server. And with this Ansible shell scripting, we install the software which is required, and we'll configure the software, and we'll deploy that application with these tools itself. That's point of view, we are going to become as a developer. As a DevOps engineer, we are the developer, but we are not going to write the functionality of application. We are going to write the code to provision the servers, to set up the platforms, or to deliver the applications. And as well as a DevOps engineer, we should know that microservice based applications, how to manage it also. That is Docker and Kubernetes. This is the hot topic in the current market. Next generation of the technology, almost the entire infra now it is going to converting into the Docker and Kubernetes. So in the CI and CD, there is a continuous integration delivery deployment process. We should know that the monolithic application, and as well as we should know that microservice based application. So this is all we are going to learn in that in the demo sessions, the keywords, everything we are going to see the demonstration from the scratch, taking from the base system on the base system. So how do you work with that? First we do the manual approach. That manual, how do we convert into that automation approach? Without knowing that manual, directly if you go for that implementing automations, we cannot perform it. Yeah, we are going to learn it about that microservice based applications, that is with the Docker and Kubernetes, that is services, how do we manage it? So we have the separate project for this. We have the demonstration of this. So these are all the expectations. So from the organization, from the recruiter. So that's why we cannot conclude it, all these things within 1 month or 1.5 months. DevOps not possible to learn it within that 1 month, 1.5 month. Nothing. You cannot, with that, you cannot make the successful of it. You should know that infrastructures to manage it, about the operating systems. After knowing about it, networks, storages, and all the things, how do you write the code for it? That's also which we should know it. But we have the ready-made solutions from the cloud provider. Before on-premises, that was a challenge. We were having the separate administrators. But now cloud is simplified. About the infra solutions, about platform related, the solutions it is giving that. We will talk it, the separate section on the cloud. Why do we need the cloud? Or why the clients are moving to the cloud? Yeah, so these are all the points that we're talking. And finally, if we conclude about it, why do they call that DevOps engineer role is, so we are going to perform the development activities. That means we are writing the code. Code writing is nothing but developer, right? But which kind of the code we are writing? Infrastructure automation. That is setting up the networks, setting up the storages, launching the servers with operating systems, and databases provisioning. So all that we are going to write as a code. But which tool? Here we use the Terraform. And next, platform automation. That is a configuration management. That is installing the Java, or installing the Tomcat, or installing about web servers, or integration of that like middleware server with the backend databases. This is a platform management. That is Java platforms or the .NET or the Python or the PHP or database. But what is the tool here we are going to use it? Ansible and shell scripting we are going to use it. Next, application. Yes, application is also important. So the developers there keep on releasing that the functionality of application. We need to define that deployment also automation. But source code has to be compiled. Source code has to be verified with quality. And running the unit test cases and packaging, yes, we are going to use it. Some build tools over there. And once those artifacts are ready, those artifacts we use that Ansible or the shell script, we distribute it. Yeah, for all these activities, we are going to write the code. And that code we are implementing is nothing but we call as a developer. But next activity is operational activities. We are the DevOps engineer. So we are doing the development activities on the integration challenges, delivery deployment challenges, to manage that infrastructure, platforms, and applications. But once that's applications, once that's the process has been designed and implemented, but we need to keep on monitoring it, right? These are all operational activities. If the server get crashed, or if that application is not working, so we should know that, like how do you troubleshoot that application? That is logs management, troubleshooting activities. Next, performance, yes, tuning of that application. Performance is yesterday, which were, that's like, aha, they have released some episodes of it. But one user is accessing, or 1 millions of the users are accessing that. Application should not get impacted to the end user. If the load is high or load is less, doesn't matter that. If I click on that, I should get response as early as possible, within the seconds. Then I feel happy with that application. So the performance of applications, and finally keep on monitoring of that application. But here, what do we do that? Monitoring tools we will use it. Logs management point of view, yes, we have those log aggregation tools. If any errors, we will get the notification, and with that notification, we check it in which server we have that errors. We'll analyze it, root cause, and we'll fix it. We have the tools, everything. Yeah, so we are going to perform development activities and operational activities to have that enhanced communication between the development teams and the testing teams and operation teams. See, we are working for those teams finally. But to have it the better coordination and communication collaboration among those teams, we are going to become as a developer and as well as operation engineer. Yeah, this is the overall about that, the main activities. So we should remember all these activities always in our mind whenever we are working with that. But what are the tools we are going to work with that? Yes, finally, let's conclude about the tools. Let me quickly conclude it. As we're talking about it in the continuous integration, source code management is required. That is Git, GitHub, we are going to use it. Source code management. We are going to learn the Git, GitHub here, GitLab as well as build tools point, that is compilation, packaging, running the unit test cases in the CI process. That is we are going to use the Maven here for the Java JT based application. Next one is code review, that is code checking, code approvals. We are going to talk at the Sonar Cube there. Next one is artifacts repository. Yes, once binary files are available, binary files we need to store it. That's point of view. Nexus we are going to talk it. Next one is like continuous integration tools. Yes, any code is updated here. Immediately pull the code and use the Maven and do the compilation and use the Sonar Cube and code quality check it and create artifact using the Maven, that artifact to store it in the Nexus and then deploy that to the servers. But who is doing that? We are not going to do that activity. We are going to take the help of these continuous integration tools, that is the Jenkins. In advanced section, we are going to talk about Azure DevOps. Next, deployment platform. Yes, we should know the Linux operating system, which we should know. Windows, that is optional. If you have that, that's fine. Windows administration. Otherwise, you can skip it. But Linux, we are going to talk it that. Around 16 or 17 classes on the Linux. And configuration management tools. That is Ansible. Very, very important tool. How fastly we deliver the change. How do you distribute that application to the number of servers? If we talk it, this is the tool which is helping. So for this Ansible itself, we have that 9 or 10 sessions on it, because we are going to start from the scratch and we are going to talk it that deeply. Not just running about the 4 or 5 commands and closing that within the 2 or 3 days. That's not enough to face that interviews or to handle the infras. And application servers, we are going to talk it like Nginx. We are going to take it one real-time application, Nginx, Tomcat, and database MySQL. All those three together. First, we'll go for that understanding manually. Then, how do you manage it? That's with the Terraform, shell scripting, and Terraform with Ansible. The manual approaches and automation approaches. We are going to talk it. And next one is the test automation tools. So JUnit we have and Selenium we have. And next one is yes, scripting approaches. Shell scripting and Python also we are going to learn it. Shell scripting is at least, and Python, if you mention that, that is added advantage. If your the resume should be filtered with the Python. We are going to look into these two scripting tools. And monitoring tools, the Nagios, Prometheus and Grafana, that is the latest tool in the current market as a continuous monitoring. Next, as we're talking that the microservice based application, that's we are going to talk it with the Docker and Kubernetes here. So Docker and Kubernetes itself, we are going to talk it like almost 17 or 18 sessions with one project, because this is the next generation of the technology. How much strong you are in that? With the Terraform, Docker, Kubernetes, Ansible, Jenkins, with the AWS and Linux, shell scripting, Python, then you will get that the easy solution to get into the market. But all these tools to become the master level, yes, you need to have some patience, some dedication about your mindset. Before whatever it is, doesn't matter that. But from now onwards, once you selected this course, how you are having that about your mindset is important. Yeah, so here the Docker and Kubernetes and cloud infrastructures. The deeply we are talking that like AWS, and we'll give that like at least which you can say there's some knowledge on that point of view Azure also, which is going to have the more weight compared with that other competitors. And issue tracking tool, that is the Jira. So these are all the tools we are going to talk it. Yeah, finally we virtualization softwares, that is with the Vagrant, VMware, VirtualBox. Yeah, these are all like on-premises solutions. Once we know on-premises, then how we are going to work with the cloud. And in this cloud, first which we should look into the manual approach, then we will go for that automation approaches. And that automation approach, the first which will work it on the monolithic application, then we will work with the Docker and Kubernetes. How to migrate that monolithic application to Docker and Kubernetes? That is, we take that one real-time application, the project, with that project, entire all these tools we are going to talk at that.